discuss first the idea of positive and negative angle measures. Consider the following two diagrams. If we measure in a counterclockwise fashion, then we consider the angle positive. That means in my picture down here, if I begin on this initial arm here, and I measure in a counterclockwise fashion to get to what we call the terminal arm, then we consider theta here to be a positive angle. Now let's consider the same picture. We're just going to reverse the roles of the initial and terminal side to look like this. If we now begin at the initial end and measure in a clockwise fashion to get to the terminal end, then our angle measure, theta, has to be less than 0, or it's going to give us a negative angle. Next, I want to talk about standard position and terminal points of given angles. We say that an angle is in standard position if its vertex is at the origin on the xy plane, and its initial side is on the positive x-axis. So, for example, I need to put my vertex here at the origin, have my initial side in blue here running along the x-axis, and then my terminal side could be anywhere. So this might be the terminal side of my given angle. So this angle here in blue is in standard position. Now, of interest to us are terminal points, and that's where the terminal side intersects with the unit circle. So here is our terminal side over here, and specifically we want to highlight that point where we intersect with the unit circle. So this red dot here is often called the terminal point. Let's determine the terminal points of the three angle measures that are given below. Let's begin with pi over 2 radians. Well, it might be helpful here for us to draw a picture. Here is our unit circle. And remember that pi over 2 radians is really 90 degrees. So that means our angle, theta, is going to look something like this, and our terminal point is going to be given up here. This terminal point is the point 0. We haven't moved left or right in the x direction, but we have moved up 1 in the y direction. The second terminal point we want to figure out is that for a measure of 180 degrees. So once again, we'll draw the xy plane with our unit circle, and 180 degrees is going to look like this. So here is our angle measure of theta, and our terminal point is over here on the left side. This terminal point is given as -1 and 0. Finally, we have one more to plot out, and that is for the angle measure of 2 pi. So let's plot in our unit circle. And a measure of 2 pi is going to go all the way around like this. 2 pi is equal to 360 degrees. So our terminal point is going to be here at this blue dot. And this blue dot here is the point 1, 0. Let's go ahead and find the terminal point of the angle measure of pi by 4 radians. Now I've drawn a picture here to help us get started. So inside here is our angle measure of theta, and we're interested in where our terminal side intersects the unit circle, which is right here at this red dot. Now, because pi by 4 is equal to 45 degrees, we could argue that this terminal side lies on the line y equals to x. This indicates that this terminal point here must be of the form x comma x. The idea is I've taken x comma y, and I know that y is equal to x, so I've replaced y with x. Next, we're going to use the fact that this terminal point also has to lie on the unit circle. That is, if I take the first coordinate and square it, and then I add to that the second coordinate squared, the sum of these two squares should be equal to 1, or the radius of our unit circle. Well, adding these together, we get 2x squared is equal to 1, or that x squared must be equal to 1/2, and forcing a square root on both sides, we get that x must be equal to plus or minus 1 over the square root of 2. Now it must be that the x value here is positive 1 over root 2. If we took the value negative 1 over root 2, we'd have a point that was down here where my red cursor is, the other intersection of the line y equals x with the unit circle. So we're going to take the positive x, so our terminal point must be given as 1 over root 2, comma 1 over root 2. One thing that I do want to note here is that if we take this point and we rationalize the denominators for both of these coordinates, we get root 2 over 2, comma root 2 over 2. So make note to yourself that these two values, 1 over root 2 and root 2 over 2, are really the same number. So you might see the different variations in various textbooks that we're working with. We say that two angles in standard form are coterminal if they share a common terminal side. So for example, the angle 45 degrees and the angle 360 plus 45 degrees are going to be coterminal. Similarly, we might say that the angle pi radians is coterminal with the angle negative pi radians. The next thing I want to talk about are reference angles. We saw on the last slide the definition of a coterminal angle. So every once in a while we're going to get these large angles, and they actually have a lot of the same measures as a smaller, simpler angle, usually one that's inside the first quadrant. And this is called a reference angle. So I've drawn 4 different angles here, one in each quadrant, and I want to show you what reference angles look like for each quadrant. The idea is we look at the terminal point of the angle in blue, and then we measure the shortest distance back to the x-axis. So, for example, if we're in quadrant 1, and our angle is in an acute angle in quadrant 1, then in green here is the shortest distance back to the x-axis. So this green angle is actually going to be called our reference angle, and you can see that it's the exact same as the original blue angle that we have here in quadrant 1. If our angle is a little bit bigger than 90 degrees, somewhere between 90 and 180, we're in quadrant 2. And in this case, the shortest distance from our terminal point to the x-axis happens to be over here. So it's going to be this angle over here that I'm going to draw in green that's going to be our reference angle. Next, if we have an angle that is in quadrant 3, this is somewhere in between 180 degrees and 270 degrees, then the shortest distance back to the x-axis from our terminal point is here, and it's going to be this angle that I draw in green that's going to be our reference angle for quadrant 3. And finally, for quadrant 4, the shortest distance from our terminal point to the x-axis is given here, and our reference angle is going to be this angle right here. Let's go ahead and find the reference angle for our two given angles. I'm going to work on the left first with theta is equal to 4 pi by 3. So let's go ahead and try to plot what 4 pi by 3 looks like. We're going to have our initial arm here on the positive x-axis, and I know that 3 pi over 3 is here at 180 degrees. 3 pi over 3 is the same thing as pi. So our angle must open up to 180 degrees and then a little bit further than that. So our angle here is going to be given in blue. And what we need to find is we need to find the shortest distance from our terminal end to the x-axis, and that's going to be given here in red. So in red here is our reference angle. So we can see from our diagram that if 180 degrees is 3 pi by 3, our angle actually opens up pi by 3 more to get to 4 pi by 3. So our reference angle here is going to be pi by 3. Moving over to our second example, we have theta equals 7 pi by 4. So once again, let's try to plot this and figure out where this is going to be. Well, 4 pi by 4 is here at 180 degrees, and 8 pi by 4 is over here at 360 degrees. So in standard form, our angle is going to start on the positive x-axis, It's going to go over here to 180 degrees and keep going all the way around almost to 360. It's going to stop just short of 8 pi by 4s. So here in red I've given our reference angle, and you can see that if we were to go pi by 4 more, we'd get to 8 pi by 4. So our reference angle in this case is going to be pi by 4. In our last example, I want to show you the use of reference angles. What we're going to do is try to find the terminal point of the angle 7 pi by 4 radians. Now remember that we've talked about this example already. If we think of 2 pi as 8 pi by 4 radians, then 7 pi by 4 radians is going to be almost a full circle. It's going to stop just short of 8 pi by 4 radians. And our reference angle, shown in blue here, is going to be pi by 4 radians. Now remember earlier that we did talk about the angle measure of pi by 4, and we tried to find the terminal point for this angle measure. The terminal point is that point on the unit circle where our angle intersects. And that point here, shown in red, was given by 1 over square root of 2, comma 1 over square root of 2. The idea of the reference angle is to use this point that we already know from pi by 4 and try to figure out what the point down here is going to be for 7 pi by 4. So if we draw a similar picture here for 7 pi by 4, and we want to find our terminal point P, it's going to be very similar to what we have up here for pi by 4. Notice that our x value hasn't changed. We're still positive 1 over root 2 in the rightwards direction. The only difference is now instead of going up to meet the pi by 4 angle, we move downwards to meet the 7 pi by 4 angle. So our y-coordinate is negative 1 over root 2. So we're going to explore this idea a bit more coming up, how we can use reference angles to solve for particular angles when using trigonometric functions. But I wanted to show you a use of the reference angles here for calculating terminal points as well. Alright, my little epsilons, stay positive.